In this JavaScript tutorial, I'm building a text-based console game called Gold Mine. It's an incremental game where you start earning gold by clicking the button on your keyboard and progress into buying automated miners and managing them. The Gold Mine is part of the full-stack JavaScript course available at js.coderslang.com, and its implementation consists of 15 stages. I'll be building the game step by step so you can follow along. The first step is to figure out what we have. On the left-hand side, there are 3 files. Package.json, you don't need to modify that one. Solution.js, where you will write some code. And task.cdsl, a file that contains the task description and essential buttons that will allow you to run your code and submit it for verification. Here you get some basic intro, which I'll skip, and immediately press the start button. Here's the description of the first stage. This is your first subtask, or rather the stage 1 of the task. You're starting with the empty solution.js file. Yeah, it's empty indeed. Create a new file, gameengine.js, and export an empty function startMiningGame from it. Import the function startMiningGame into solution.js, and call the function startMiningGame after importing it into solution.js. Nothing should happen as the function is empty. It's okay. Okay, let's go ahead and do this. Create a file, gameengine.js. New file, gameengine.js. Export function. What's the name of the function? startMiningGame. An empty arrow function. And now I need to import this function into solution.js. Import startMiningGame from gameengine. And what's next? The third step is to call this function in solution.js. That's what I'm doing. startMiningGame called. Okay, cool. Let's try to run the code. And I got some error. Can't find module. Okay, this is a relatively common thing. It should be fixed by adding the .js extension to the import. Go ahead and rerun the code. Okay, now there's no error, and indeed nothing happens as expected. The code is implemented, so I'm submitting this task for verification. Here are the submission results. The status is done, so I can move to the next stage. The next stage goes like this. Our game should interact with the user in 2 ways. It should know how to accept the keyboard input, and it should know how to print messages to the console. You're already familiar with console.log, but this time I suggest using an npm module terminal kit. It will provide us with all we need for the task, plus a couple of very handy utility functions that will allow us to change our position on the screen, clear the screen, and handle user input. Start by installing it by running npm install --save terminal kit in the terminal. Let's do it. npm install. Oops, I got it wrong, unfortunately. I need to fix it. The npm install should happen from inside of the folder task 250. So I do cd task 250, and then I do npm install. Back to the task description. Second step, create a new file, constants.js, and place the line import terminal kit from terminal kit in it. Okay, constants.js plus constants.js. Import terminal kit from terminal kit. After importing the module, add the line export const term equals terminal kit dot terminal. That's what we're going to do. Export it. Submit. All green once again. Moving on to the third stage. Stage 3. So you've already exported the constant term that will allow us to control the terminal. Let's make some use of it. Create the file functions.js and export the function init from it. Create the file functions.js and export the function init. Export it. Function init should have a single parameter term. Import the function init into gameengine.js and call it from the function startMiningGame. Import init into the gameengine.js. Okay, so there should be a single argument term, and game engine I should call init. So I believe I should import it, but nothing's been said about it yet. So let's see if it follows on. Add the parameter term to the function start mining game. Import the constant term into solution.js from constants.js. Pass it into start mining game, and then call init term from start mining game. Inside of the init function, add the line term welcome to the mining game. Okay, I'll first do this thing because it seems straightforward. I will go to constants, functions, init, just copy and paste this line. Now add the parameter term to the function start mining game. Start mining game term. And then it should be passed on to the init. Okay, let's check that everything's correct. Import the constant term into solution.js. Okay, I have not done it yet. From constants.js, pass it into start mining game, and then call init term from start mining game. Import term from constants.js, and then pass it into start mining game. Start mining game accepts term, and then calls init, passing the term on. And then term is called with the parameter welcome to the mining game. Okay, looks good. So we run the code right now. It should display the string welcome to the mining game. But unfortunately, it says init is not defined, so we have missed something. Game engine.js, of course, have not imported init yet. Import init from function from /functions.js. Let's rerun the code. But there's some weird symbol at the end. Let's check what might be wrong here. Welcome to the mining game. We type the last character and we run it. Okay, maybe it's just something with my terminal here. It prints this percentage sign at the end of line. Let's try to submit the task to verify our implementation. Okay, all green, status done, and we can move on. Stage 4. Congratulations on passing the stage 3. You might be wondering why we have 4 files, a third-party module, and quite a few lines of code to output a single message on the screen. Yeah, that's indeed a good question. And the answer is that this structure will allow our code to be flexible, easy to modify and maintain. Ultimately, the payoff will be evident. Before we can let our user mine gold, we need a place to store it. Makes sense? Let's create an object config with a single property gold with the value 0. Config, okay, created where? Export config from the file constants.js, import into solution.js, and pass into start mining game as a second parameter. Okay, I need to create config in constants.js, export it, import into solution, and then pass into start mining game as a second parameter. Okay, sounds good. So start in constants, export const config, which is an object, single property gold, initial value 0. Now import it into solution.js. Import. Oh, I don't need another line here. I can import just here. Config and pass it as a second parameter into start mining game. Running your code. Okay, still running. And submit. Submission successful, which means that the implementation was correct. Moving on to the next stage. Stage 5. Now let's work on the function that will be called if the user clicks the key G on the keyboard. Implement and export the function handle key press term state in the handlers.js. We don't have this file yet, so I will create it. Handlers.js handle key press term state. Export const handle key press, which is an arrow function with two arguments, term and state. For the reasons that you'll understand in the next task, we need to make it a closure. Okay. In other words, handle key press term state should return another function with three parameters: name, matches, and data. That's fine. We can do it. So instead of a regular function, it should become a function that returns a function. And then it says we're only interested in the key that was pressed, and it's stored as a code in the field data.code. You can use string from char code to convert the code of the key into the actual symbol. If the key is equal to G, capital G, or lowercase g, it should increment the property gold of the parameter state by 1. Remember that we import term and config only into solution.js and then forward them as term and state. Okay, so I need to wrap my head around this. So in this handles.js file, I have some closure that captures those arguments, term and state, and then we have a function name, matches, and data. The key pressed will be in this field data.code, and then I can convert this code into the actual key pressed using string from character code. Okay, let's do it like this, something like const key equals string from char code data.code, and then if key equals G or key equals lowercase g, we say state.gold++. Okay, do we need to do anything else in this task? We're still not calling this function handle key press from anywhere, so it's just looks like a raw implementation. If the key is equal to G or G, it should increment the property gold of the parameter state by 1. Okay, we've done it, and we have not done any extra imports. Let's run the code. Should still work. We should do the same welcome message. Submit the task. Great, all green. Moving on to the next stage. Stage 6. The handler is ready, so we need to connect it with the key press event. But before that, we need to improve the init function. It accepts a single parameter and should call on it. Clear, hide cursor, and grab input. Okay. The function names are self-explanatory and will help us start working with keyboard events. Yeah, looks like this clear thing will clear the terminal, hide cursor will hide the cursor, and grab input will allow us to grab keyboard input. Inside of the start mining game, after calling init, call the function term on event handler. This function accepts two parameters. The first one is a string. As we want to handle keyboard events, we'll set it to key. The second one is a callback function, which has three parameters: name, matches, and data. Oh, looks terribly similar to the closure we just implemented in handlers.js. We've already implemented the appropriate closure on the previous stage. That's right. Time to use it. Okay, so let's start from init. It accepts a single parameter and should call on it. Clear, hide cursor, and grab input. Init. Where's our init? In constants? No. In functions? Yes. Okay. So, right at the very beginning, we'll say term.clear, term.hide cursor, and term.grab input. Inside of the start mining game, after calling init, call the function term on event handler. Okay, term on key, handle key press. Inside a start mining game, game engine, start mining game, term Oh, okay, makes sense. It looks like I have forgotten to add the state here. It's called start mining game term config. Here it becomes a state. Now I need to check the description once again and start mining game after calling it, call the function term on event handler. Okay, just copy paste it. Term on key, handle key press. Handle key press from handlers.js. Okay, but it should not be the handle key press itself. It should be the function returned by handle key press. Term and state. Let's even make it more explicit. Let's say const key press handler. And do it like this. Key press handler. So here I'm calling the function handle key press, passing in 2 arguments, term and state, which in turn will give me the handler with the 3 arguments, name, matches, and data. Let us run the code to see what happens. Great. The change is sort of evident. The console is clear now, and the only thing that we see is welcome to the mining game. Control C to exit it. No, it doesn't actually exit. That's weird. What happens if I click run your code again? Run your code. Nothing happens. Okay, fine. Let's submit the task to see whether the implementation was correct. Yep, the implementation was correct. The status is done. And we're moving on to the next stage. Stage 7. So now we can start mining gold in manual mode by pressing the key G. Oh, I have not tested it. It would be interesting. Let's print the result of our actions on the screen. Implement and export the function update gold term state from functions.js. Let's do it immediately. Functions.js export const update gold. We're exporting this function. It should move to the coordinates 25, 2, erase everything that comes after it, and then print the property state.gold in yellow color and bold font followed by 3 spaces. Once you've implemented update gold, you can call it from handle key press and update the gold value when the user hits the G key. Okay? Use functions term move to X, Y. So obviously move to 25, 2. And term bold yellow message and term erase line after. So in update gold, first thing that I need to do is move to 25, 2. Term move to 25 and 2. And then I need to display current gold in bold yellow font. Term bold yellow, message, and our message is state.gold. Once you've implemented update gold, you can call it from handle key press and update the gold value when the user hits the G key. Update gold. Okay. Go to handle key press, handlers.js, handle key press. We update the gold value in the state, and then we call the update gold function to reflect this change. Let's run the code and hit the button G a couple of times. I'm hitting the G button, but nothing happens. What might be wrong here? To try to find what's wrong here, I go to solution.js because that's the entry point into the game. In solution.js, I import start mining game function and 2 constants, term and config. So then the only thing that we're doing is calling start mining game, which does this init thing. Init calls clear, hide cursor, grab input, and displays the welcome message, welcome to the mining game. Everything seems logical here. Then key press handler is initialized as the result of handle key press. And here we do update gold. Maybe something's wrong with update gold. Update gold, term state, term move to 25, 2. Term bold yellow state gold. Oh, of course. It looks like I have not passed the term and state into update gold. Let's retry. Looks like there was some glitch which prevented the code from running. And now I click run your code and I press some button like 1, 2, 3, nothing happens. If I press the G, there's an error. The error says update goal is not defined. Let's go into the code that handles the key press. And indeed, update goal is not defined, which means it has not been imported yet. Import update gold from /functions. Now let's try to rerun the code. We press G here. It works. And we're earning some gold. Looks good, so let's submit the code for verification. Status failed. Wow, cool. Update gold should clear the output location by calling erase line after. Erase line after. That's fine. Erase line after. Term. What else? What else is wrong? Update gold should print the current gold value in yellow bold font. I believe we were already doing this, so strange. The string printed by bold yellow should end with 3 spaces. Okay, we have not done that. I will fix it immediately. Update gold, state gold, plus 1, 2, 3 spaces. Let's rerun the code, make sure it still works. Rerun the code. G. Okay, still works. So let's close it and resubmit the task. All green now, moving on to the next stage. Great, the manual mode is done, so we should think about automating our mining empire. Add new field producers to the config constant that is exported from constants.js. New field producers. It should be an array of objects. Each element of the array each producer should have properties ID, title, cost, growth rate, base production, and count. Here are the examples of what producers might look like. ID 1, title minor, cost 10, growth rate, something, base production, something, count 0. Okay, I will actually just copy and paste those to simplify my task. Constants, producers. Producers, an array of objects. The first object, the second and third object. Add comma here and format the code a little bit. Okay, so we have minor, adventure, and professional. Let's see if we need to do anything else. Each producer must have a unique ID. ID 1, ID 2, ID 3. Looks like everything's good here. Let's submit the task without writing the code, because the only thing we've done was adding this producers field into the state, into the config object. Unknown submission error. Interesting and weird. Let's just try to resubmit the task. Okay, the glitch is gone. We got back the submission results. All green, which means we can move on to the next stage. Stage 9. Now let's add the ability for the user to purchase new producers. If you have created producers with single-digit IDs, you did everything right. If not, you can still fix it. In this task, you should only modify the handle key press function. If user presses the key that corresponds to the ID of a producer, and they have enough gold to buy it, then we should deduct the cost of the producer from the gold balance, increase the cost of the next producer by multiplying the current cost by the growth rate, increment the count of the producer that was purchased. Okay, those 3 things. Deduct the cost of producer from the gold balance. Okay, we spent the gold to buy the producer. Increase the cost of the next one. Makes sense. Each next producer will cost more than the previous one. And then increment the count of the producer that was purchased. Makes sense once again. We purchased it, so the count should go up. Go into handle key press and implement the if statement if user presses the key that corresponds to the ID of a producer. Handle key press function. Handlers, handle key press. So if key equals, okay, we need to actually look up the state for our producers. And we'll say if state, no, not if state, let's do like const producer equals state dot producers dot find producer PID equals, or rather, let's actually check whether it's a number or a string. Constants. Okay, here it's a number. So we need to do some loose equality here. Producer, and then if producer, and the user has a null gold, and producer.cost is less than state.gold, then the user can purchase it. So we say state.gold minus equals producer.cost, state, no, nothing else in the state, producer.count plus plus, and producer.cost multiplier is producer.growth rate. Growth rate. Okay, looks good to me. Let us submit the task to verify it. The verification completely failed. Okay. Handle key press shouldn't have any effect on the state if the user has pressed the irrelevant button. Interesting. Let's try to fix this first. So, producer equals state.producers find PID equals key. Let's add some debug statements to see actually what's going on right now. Let's say console.log pressed plus key. And here, let's say console.log found producer plus producer. Now I'll run the code, and we run the code to see what happens if I click, for example, 5. Oh, there is an error. ID is not defined. ID is not defined. Oh, of course, ID is not defined. What was I thinking? Handle key press, PID. It should not be PID, it should be P.ID. Of course. Try once again. Run your code, press 5, pressed 5, found producer, undefined, good. Pressed 1, found producer, found some producer. Pressed 3, found something. Press G, and we are mining gold. Great. Stop this and resubmit the task after deleting those console logs. First console log is gone, and the second one is gone. Submit. Great. Now we fixed everything, and we can move on to the next stage. Stage 10. After implementing a producer purchase, we need to make sure that they do the work. Each second, the producer should give us the amount of gold equal to their base production. Add a new field, production rate, to the config object exported from constant.js. Initial value of production rate should equal 0. Production rate to the config. Constants, producers, gold. We'll add production rate equal to 0. When the user purchases a new producer, we should increase the global production rate. Implement and export a handler, handle state change, term state, in handlers.js that should call a function update gold, term state. Okay, I implement and export a handler in handlers.js that should call a function update gold. Handlers, export const, handle state change is a function that calls update gold term state. In the update gold function, increment the value of gold by production rate each time it's called. In start mining game, set the interval that will call handle state change once every second. Let's start with this thing. In the update gold function, increment the value of gold by production rate each time it's called. Functions update gold, increment, so state.gold equals state.gold plus equals state.production rate. Feels weird because right now it will increase this production rate on each click, increase the gold, but maybe not. Maybe I'm getting a little too far ahead of myself here. In start mining game, set the interval that will call handle state change once every second in start mining game. So game engine, start mining game, we do set interval, and the handler is handle state change, which we need to import from handlers.js, and it will be called once second handle state change. Okay, I need to the anonymous function here, handle state change term state, something like this. Handle state change should be a closure and return a function in order to be used in a set interval. Okay, that makes sense now. Remove the call to update goals from handle key press to avoid accounting issues. Okay, makes sense now as well. So handle state change should be a closure and return a function. Remove the call to update goals from handle key press to avoid accounting issues. Let's start with the easier thing. Handle key press, handlers, handle key press, remove update goal from here. And now on to the handle state change should be a closure. So we'll return a function term state, update gold. Here we will handlers.js, we'll just call, no, not handlers, where we, set interval. We'll just call handle state change, which will return a function that will be called once every second by the set interval. Let's run the code and see what happens. Welcome to the mining game. Okay, we have 0 gold. Let's click G a few times. Okay, now it updates every second. So if I click faster than once every second, it will do something faster. What if I purchase some producer? Let's say I click 1. Okay, the gold is down. Good. Press 2. Nothing happens. Probably the price of the second producer is higher than the amount of gold I have. Press 1 again. Okay, good. It goes down. Looks like I'm purchasing new producers. So submit task and see what the verification results bring us. Verification failed. The total production should increase correctly after each producer purchase. Total production. Let's see. Handlers, we increase the count and then total production. Okay. So we haven't increased the total production here after the purchase. But we need to do something like state dot asset call production rate plus equals producer dot base production. Oh, actually, if I run the code right now, if I rerun the code, I should be able to mine this gold automatically. Click G a few times, and now I'm buying first producer by clicking 1. Clicked 1. Great. They're mining gold for me. I could sit back and relax. Maybe buy another producer. It works. Great. So yeah, let's stop it and resubmit the task to move on. Status is done, and we can move to the next stage. Stage 11. The core of our mining game is implemented now. However, there are a few cosmetic things that we need to work on to provide pleasant user experience. For starters, we'll improve our config by adding 2 flags. Isn't it completed false? And is producer list updated true? You'll need them in the upcoming stages. That sounds easy. Constants, config, first flag, second flag. Submit. All good. Verification succeeded. Next stage. Stage 12. The prep is done, so let's start from the beginning. Once the user has enough gold to purchase the first producer, it makes sense to change the welcome message. I suggest creating a function check init completed that should be called from handle key press once the user has enough gold to purchase the first producer. Here's how check init completed should work. Okay, create a function check init completed that should be called from handle key press. Functions, export const check init completed, which is some function. Import it into handlers and call it from handle key press. So let's call it immediately. It should accept forwarded arguments term and state. Let's do it. Check init completed term state. Add term and state here. And it should move to the beginning of the first line. Erase it and print the message. You can purchase producers by clicking the number button. 1, 2, 3, and so on. Move to the beginning of the first line. How are we doing this? It's something like term move to 1, 1. Then erase it. Term erase line after. And print the message. It should print the message gold and production rate on lines 2 and 3 respectively. So move to the second line, term move to the second line, print term gold, term move to the third line, and print term production rate. Looks good to me. It should be called from handle key press if the user has enough gold to purchase the first producer. Okay. Don't forget that the transition from the initial welcome message should happen only once. The transition from the initial welcome message should happen only once. Okay, this is where the init flag will come handy. Even though the function handle key press should be called multiple times, check init completed should only be called once. Okay, so handle key press, check init completed should be called once if the user has enough gold to purchase the first producer. And we have this is init completed flag, so we can depend on this flag. And if this flag is true, plus the user has enough gold to purchase the cheapest producer, only in this case we will need to call this function check init completed. Good. So we'll say if state dot is init completed, if the init is not completed, and state dot gold is greater than or equal cheapest producer dot cost, which we actually don't have yet. We'll call this function check init completed. Now we need to find the cheapest producer. Cheapest producer will be, how will we actually find the cheapest producer? We can do something like, we can reduce the array of all the producers to a single producer with the lowest cost. So state dot producers reduce previous current, and the initial value will be producers, or the initial value will be some object, but cost is going to be number max value, and then if previous dot cost if current.cost is less than previous.cost, return current. And this should give us the cheapest producer. So if not state isn't it completed and state.gold is greater than or equal to cheapest producer.cost, then we check if init is completed. Looks good to me. Let us run this code. Welcome to the mining game. Press G a few times and we immediately get there. Cannot read properties of undefined, reading cost. Of course, we can't read the properties of undefined because initially there is no cheapest producer, probably. Let us see. Handlers.js line 529. Looks like I messed up this initial value for the reduce function. Okay, the problem here is that I have forgotten to return previous cheapest producer if the next one is not cheaper than the current one. This should fix the issue. Let us test it. Press G a few times. And now we have gold, we have production rate, and we can buy someone. Let's click 1. Gold is changing. The production rate is not being displayed. Maybe it will be implemented in the future stages. Let us stop here and submit the task for verification. Submit task. And it failed. Check init completed should be called from handle key press only once for the life of the game. Okay, what might be wrong here? Handlers, cheapest producer. Okay, check init completed. Is it okay? I'm not flipping this init completed flag. So go into check init completed, and I will flip that flag. State is init completed equals to true. Let's resubmit the task. Everything's good with submission now. On to the next stage. Stage 13. Now we're going to improve the UX by displaying the current list of producers. We'll implement the function update producer list term state in functions.js. It should print the list of producers, each on the new line starting from line 5. It should only print the producers where the count is greater than 0, plus 1 producer with the 0 count. Show the user what's their next objective. The output format should be like this. -2, production per second cost, then the name of the producer, production per second, and cost again. Production per second and cost should be rounded to 1 digit after the decimal point. Okay? Update producer list should be called from handle key press every time there's a need for it. Update producer list. Good examples might be the transition from the initial welcome message in checking it completed or purchase of a new producer. We'll implement the function update producer list in functions.js. Okay, let's do it. Functions.js, export const update producer list. It's going to be a function. And what this function will do, it should print the list of producers, each on the new line starting from line 5. So let's go to functions.js and let's do this. Term move to 1.5 to move to the beginning of the 5th line. And let's print all the producers. So I'll loop over all the producers with for each. So say state.producers that for each producer, I'm going to do something. In this something, I will need a producer. Actually, I will need just 3 properties of a producer, or maybe 4. Title, count, base production, and cost. And I will print the producer. How it should be printed? Let's see. Okay, let's copy and paste this. Let's call it expected format. minor. So we start with the title, followed by the count, followed by production per second, followed by cost, and followed by the new line, because we want to move to the new line. Now let's see what else is required here. It should print the list of producers, each in the new line starting from line 5, we just did it. It should only print the producers where the count is greater than 0. Okay, need to check it. The count greater than 0, plus 1 producer with a 0 count to show the user what's their next objective. So I will introduce the Boolean flag called has printed last producer equal to false by default. And if I have not yet printed the last producer, I will print the current one. And if the count of the current producer is equal to 0, then I will flip this flag to true and say that we have just printed the last producer and we don't need to print any other producers. Let's check the task description once again. Production per second and cost should be rounded to 1 digit after the decimal point. Have not done this yet. And update producer list should be called from handle key press every time there's a need for it. Update producer list should be called from handle key press. Okay, so let's focus on one thing at a time and start by rounding base production to fix and the cost to fix 1 as well. And let's check the constants and notice this is producer list updated flag. It starts from true. So in handlers, when the user purchases a new producer, we want to say state is producer list updated equal to false. And then in the very end here, say that if the user has just purchased a new producer, so state dot is producer list updated. In fact, if it's not updated, we want to call update producer list term state. Import it in the very top here. And let's try to run this code to see the previous. Rerun it. Welcome to the mining game. G. Okay, works good. But we don't see any producers actually. That is weird. Press 1. We purchase 1 producer. We purchase the second producer, but we don't see the list of all producers. Something is wrong here. Let's go into functions, update producer list, state producers for each. Of course, we haven't printed last producer yet. We need to print the current one. Let's see if this fixes the problem. Welcome to the mining game. G. A few more times. 10. Now we have enough gold to purchase the first producer, but nothing changes. Okay, 11. No, we still don't see the producers. We buy 1, but we have not seen this initial producer. Never saw the option to buy the miner. Let us check what's wrong here. Let's try to look for hints in the task description. So update producer list should be called from handle key press every time there's a need for it. We've done it. Good examples might be the transition from initial welcome message in check init completed or purchase of a new producer. Okay, we've done this purchase of a new producer, but not the transition from the initial welcome message in check init completed. Okay, so check init completed. In functions, check init completed. Yeah, so here's state dot is producer list updated should be set to false, so that the next time when we call update producer list, Now, next time when this handler is activated, it will see that the producer list hasn't been updated, that we should update the producer list. Let's test it. Run the code, press G a few times, and great. I see now that I can purchase the miner. I will purchase it. G a few more times. Let's try to purchase this adventurer for 100 gold. Pressing G like a madman. G, 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 G. Bought another miner, and now I buy the adventurer. Okay, and then the third line, I can buy the professional for 1,200 gold. Looks like it works, so let us try to submit the task. Status failed. Let's see where we failed. Update producer list should set the flag is producer list updated to true once it finishes the update. Update producer list should set the flag is producer list updated. Okay. Update producer list. Fine. Let us do it. State is producer list updated equal to true. Yeah, indeed, we have finished the update, so we need to flip that flag. Let's resubmit the task. Great, all green, all green. Next stage. Stage 14. Wow, the previous stages must have been hard. We still have some work to do though. It would be very useful for the user to see the current production rate of their mining empire. Let's display it on the third line in green color, term.green, right under the current amount of gold. As we need to display this number only when we purchase the new producer, you can add the necessary code into handle key press. Okay, term green and the current production rate of their mining empire. Right under the current amount of gold. So go to handlers and actually let's go to functions to see where we display the current amount of gold. It's 25.2, so right under it will be 25.3. We want to move in handle key press. When we buy a new producer, at the very end, we will move to 25.3 and display current production rate in green. Term mean state dot production rate. And then maybe let's add few spaces like we did with the gold. Run your code. Welcome to the mining game. Press G a few times. Buy the producer, and we see the production rate in green. Great. Buy new producers. The production rate changes. Looks great. Okay, time to submit the task. Status is done. Moving on to the next stage. Stage 15. You might have noticed that there are occasional issues with displaying the numbers in our game. Sometimes there appear long, weird tails after the decimal point. The other times, the numbers get so big that it's hard to make sense of them. Let's implement the function formatNumber in functions.js that should take the number and return a string representing an improved versions of it. Here's how it should work. If n is less than 1,000, it should be rounded to a single digit after a decimal point. Else, to cut down the length of a number, we need to use the letters K, M, B, and T to represent thousands, millions, billions, or trillions. We're not really interested in being super precise here. So we'll then round the result to 2 digits after a decimal point. Examples, some example of rounding to 12.35K, some 1.23 million, and 12.34 trillion. Change the output format of gold and production rate using the format number. You can include it into other places like the list of producers, although it's not mandatory. Yeah, I need to implement some function format number in functions.js. Go to the very bottom and say export format number. Just some function that takes number n And if n is less than 1000, it should be rounded to single digit after decimal point. Okay, and it looks like n should return a string because we're working with strings here. So if n is less than 1000, we just return string n to fix 1. Okay, we're rounding it. Then we'll handle the extra units like thousands, millions, billions, and trillions. So we'll say const units is nothing for everything under 1000. Then K, M, B, being quotes, and T. Well, actually, I'll rename this one to value. So make a val here because we're formatting some value. And then the second step would be to understand whether our value actually fits into this fixed units. Thousands, millions, billions, and trillions. So we'll say, then I'll check if it fits into the thousands, millions, billions, and trillions by doing a little math trick. Const n equals math lore, to round it down, of math log val divided by math log 1000. And if this n happens to be less than the length of the units, then unit will be unit, which we need to declare here, flat unit. Unit will be unit of n. And at the end, I will return the string of number, that is math floor, m multiplied, n. I have forgotten to add m here, which is equal to math val divided by math to the power 1000 to the power of n. And the return value will equal math floor m multiplied by 100. Actually, by 100, not sure. Oh yeah, because we're rounding to the 2 decimal points, divided by 100 to fix 2 plus unit. And let us check the result. Actually, to make sure we're working with big numbers here, let's change the production here to something like some big numbers and run the code. Oh, no, sorry, I have forgotten to use this format number thing. Where do we need to apply it? Format number. Change the output format of gold and production rate using the format number. Okay, so in handlers or in functions, state.gold, I changed to format number of state.gold. And then in handlers, I changed to format number, state production rate. Now let's run the code. Welcome to the mining game, and everything crashed. Cannot access n before initialization. Oh, of course, because it's not n anymore, it's val. Whereas g a few times, byte minor. Crashed again. Format number is not defined. Of course, needs to be imported. Format number. Run the code again. Wouldn't crash this time. Buy the first producer. Now I'll be buying those producers very quickly. Production rate looks good. Let's get somewhere higher to see. Okay, first transition to thousands worked correctly. Production rate is high. Gold is in the thousands. Let's get to millions. Getting closer to the million. Let's see if it transitions correctly to 1,000,000, 900K, 970, 1 million. Okay, looks like it works. So let's stop it and submit the task for verification. Done. Looks good. Next stage. At the moment, we're updating the UI only once a second. It's okay, but it'd be a lot smoother if it was updating more often. Let's say 10 times faster. You'll need to change the code in quite a few places. So let's add a property tick speed to our config object to make the transition to a different refresh rate smooth and easy. Tick speed, okay. Tick speed to the config. Tick speed will be what? I don't know, 100? 10 times faster. Oh, okay. So right now we're updating every second, 10 times faster, which will be every 100 milliseconds. Start by passing tick speed as a second parameter to set interval, and then think about what you should do next. Remember that you should also account for tick speed change in the amount of gold you add to the bank on each tick. Start by passing tick speed as a second parameter to set interval. Whereas the set interval is somewhere a solution, our game engine set interval. Okay, so it will be state dot tick speed, state dot tick speed, right? Yeah, and then where we increase the gold, so the tick speed will mean that this handle will be called a lot more frequently. Not the handle key phrase, but probably handle state change. But it's the handle key press where we display the production rate. So the production rate should become state that production rate is production rate per second. So it will be multiplied by 1,000 divided by tick speed. If tick speed would be 1,000, nothing will change. It will be the same production rate. And if tick speed is less than 1,000, like let's say 100, it will be the production rate will change. And we'll need to also change the production rate here where we go to the base production. We'll multiply by tick speed and divide by 1,000 because it's still production rate per unit of tick speed. Is that enough? I don't know, but let's see. And let's actually add a few more producers. I want 2 more. I want 2 more here. Let's call them 4 and 5. Professional, let's say like mining factory, and the spaceship cost will be higher, like maybe a lot higher. The growth rate will be here higher, here lower, and the base production will be a lot higher as well. Run the code to see what changed. Buying miners, okay, something broke. Tick speed is not defined. Of course, tick speed is not defined because I have not imported it. Oh my god. Handlers, tick speed, it should be state tick speed. Here, state that tick speed again. And where else have I used it? Tick speed. Okay, looks good now. Let us run the code. Click G a few times and buy first producer. Okay, it works, and gold updates a lot more frequently, so looks a lot smoother than it used to be. Let's buy some more producers. Buy more, buy professional. Now we can buy mining factory for 12K. Buy mining factory, buy spaceship. Okay, buy spaceship. And our production rate is in millions now. Nice. Nice. Submit task. And looks like we're done. Congratulations. It's been a tough road, but you've made it. You can make a number of improvements to the game. For example, make format number handle numbers greater than 999.9 trillion. Next could be something like AA, AB, and C, and so on. Yeah, sounds good. You could improve the UI, add X for producers, make the game easier or harder by changing the producer stats. And then there are some contact information from the creators. Okay, that's it. It looks like I have solved everything, so let me try to run the code and play the game a little. Pressing G, buying producers, buying more producers. Yeah, that feels unbalanced. Feels like I'm buying those too quickly. Let me think what I can do with it by updating this config. Okay, so here's the updated producers list, which provides some balanced gameplay. We started with minor for it cost 10 and base production of 0.1, move to adventure, cost 100, base production 1, professional, base production 9, cost 1200, manager, cost 11,000, base production 55, extractor with cost 150,000, base production 210, cartel, cost, well, a lot of zeros here, and base production 1,000, factor with a base production 7K, monopoly with a base production 52K, and a robot with a base production of 252K. Let's see if it's playable. How do I do this? Test DSL, run your code. Welcome to the mining game. G. Let's buy miner and let's keep pressing G. Still buying miners. Time to buy an adventurer. I need 100 gold to buy an adventurer, so clicking G, getting closer. 100, buying adventurer. Still hitting G. I need 12. I need 1,200 to buy professional. Wow. I'll probably buy another adventurer now. Bought another adventurer, and I'm still clicking G. Maybe I should stop doing it. Okay, stop clicking G. Okay, I'll buy another adventurer, and I'll go away from keyboard to wait until I have enough money to buy the professional. And I'm back. Looks like we have enough money to buy the professional. We will buy it. Buy it by clicking 3. Okay. Yeah, but to buy the manager, I need 11K. 11K, that will be a lot of time. Okay, I'll probably buy another professional right now. Wait a little bit more. And then buy the manager. And then maybe call it a day. Okay, 2 professionals, 3 adventurers, 8 miners. Let's make 10 miners. Maybe 5 adventurers. Another adventurer. Yeah, 5 adventurers, 2 professionals, and then we will wait for a manager. I changed my mind. I don't want to wait until I have enough to get the manager, so I'll buy 2 professionals right now. Buy 1 professional, buy another professional to get my production rate up. I'll buy even adventurers. I want to get my production rate up to 50. And then when it's 50 per second, I'll probably wait. Okay, after 50 per second, now it's time to wait. Okay, I have enough money to buy managers, so I will do it. Now production rate is 105 per second. But the next one is at 150K. Oh my god. Maybe I'll wait a little more to just spend all this gold and see whether I can get this production rate up to 200. Manager 1, extractor 0, professional 4, 13 adventurers and 10 miners. I need 12K, 12.5K to buy another manager. Almost there. 11K, 11.5, 12.5. Okay. Put another manager, and then I'll just spend everything on professionals, venturers, to try to get this production rate up to 200. Maybe I'll buy more miners, actually. I only have 10 miners, so 20 miners. Maybe let's do like 30 miners, okay? 30 miners, production rate 173, 15 adventurers, 5 professionals, 2 managers, and 0 extractors. I need 27 more production to get to 200. What can I buy here? Yeah, let's buy another professional. 182. Yet another professional, 191, and one more professional, and I will get to 200. Almost there. Need 3K. Now I'm at 2K. Gold. Yep, bought another professional. Got to 200 production per second. So that's the game. I can maybe reset task progress and delete everything if I want to re-implement the game. Or maybe I can modify this config, maybe add a few more lines here to make this game even longer and even more interesting. But in essence, that was it. Thank you for your attention, and let me know what you think.